Hey everybody, welcome back to Deterministic. I'm Brandon Conkle, and today I'm taking a detour into something that I've been interested in for a long time now. I've recently taken the time to get it all set up on my system, and the results have just been astonishing and a whole heck of a lot of fun to play around with. So I'm talking about Stable Diffusion and AI art generation. Stable Diffusion is an open source toolkit or library that allows you to use AI trained models. From what I understand, I'm not an expert here, but my understanding is that it comes originally from removing noise from images. So these models were originally trained with the intention of clearing away noise, static, compression artifacts, things like that from images. And over time, through many steps or iterations, it comes to images that match text prompts of what the user wants to see. And it's really just a fascinating process. My favorite toolkit for working with it, Invoke AI, was recently updated to a version 2.1 that adds a really exciting new feature that was previously only available through the CLI. And that is Inpainting, allowing you to replace selective regions of your picture with AI-generated substitutions, and the results are really fun. So I want to take some time to show you around and show off what Invoke AI can do. It's a really fabulous web UI around all of this. I didn't have anything to do with it personally myself. This is entirely open source, worked on by a community that I am not a part of, so I am taking full advantage of somebody else's work. I really appreciate that the community has shared this work, and the results are just stunning. This UI here makes it really easy to work with Stable Diffusion, and it's a whole lot better than the CLI-driven workflows that I've experimented with in the past. Like I said, this is a community effort. Invoke AI version 2.1 is releasing soon. It's still, he created the tag to release it, but it's still in the release candidate branch. I think they're doing some maintenance on the main branch before they actually merge it over, but it's practically ready at this point. It's gone through multiple release candidate processes. Let me see. I think it had 4 release candidates. Yeah, so here's 2.1, 4 different release candidates, and now we're just about there on this final release. The Inpainting support is really the most exciting thing, but it's not the only thing that's changed. The Invoke AI project originally started off as one of the earliest forks of the core CompViz repo, where Stable Diffusion came from. It was formerly called L. Stein Stable Diffusion, and it was started by Lincoln Stein here. I'll pull up his profile. He's from Toronto, Ontario. Appears to work at the Ontario Institute for Cancer Research, so that is really cool. And thank you, Lincoln Stein, for sharing this project with the community. So he mentions there that it's evolved into a full-fledged community-driven open source Stable Diffusion toolkit. And like I said, it really makes it so much easier to work with all the cool things that Stable Diffusion can do. They have a homepage out here at invoke-ai.github.io/invokeai. You can get to it from their GitHub page. It has a set of easy install instructions. I'm using it on Windows because I use this machine for not only programming but also gaming, and so I have an NVIDIA RTX 3070 card, one of the Founders Edition cards that comes straight from NVIDIA in my machine right now, and it turns out that's just good enough to be able to work with this Invoke AI toolkit here. It's not quite good enough to train new models or to continue to train the models to add things like my own picture or pictures of other people around me. It's not powerful enough. I'd need a 3090 or better to do that, but I can take advantage of the already trained models to do some pretty awesome things. So the setup instructions, I'll go through how I set things up first. I'll go through how to start it and some of the features that it has built in already before the 2.1 release. And then I'll talk about Inpainting, the big new feature in 2.1, and how that works. And I'll show a little bit of my process. I'm still very amateur at this. I'm still just playing around with it, but I've had fun learning about it. So Windows install instructions here. I originally did what they said and used Miniconda to set up a virtual environment for my Python Stable Diffusion development. Since then, I have moved to the alternate instructions that they link to here. They link to this easy peasy Windows install. It includes a more CLI driven workflow, I think, based on Pew, which is a virtual environment library or a tool to help you manage versions between different Python environments. Python is obviously the most widely used language and ecosystem for machine learning and AI-driven things. So it makes sense that this is in Python and that we're using tools like pip and u to get started with it. I started with this install Windows instructions, but then I went over to the easy peasy Windows install wiki page here, which gives the information about running Pew and setting things up in the CLI. I think easier than Miniconda or Anaconda was for me to work with. One thing that I also like about it is that I can run everything without being in a elevated privileges admin instance of the shell. I can do it all in the user shell, which I appreciate. The instructions talk about installing Python. I just installed the Python from the Microsoft Store because it was simple and easy. I installed Git with Chocolatey, which is a Windows package management tool. I did install the PowerShell 7 here. I followed the instructions here to clone the repository. That's the terminology for copying everything down or downloading everything from GitHub in a way that you can contribute back upstream if you want to, or if you're able to. And then I created the virtual environment here. But then I ran into a problem when I got to this Python scripts preload models step. I didn't the first time. I've come back to this after letting it sit for a couple of weeks. Originally, I didn't have any trouble here, but recently PyTorch, one of the big dependencies of this project, was updated to a new version that broke compatibility with Windows. It used a sigkill signal that is not supported on Windows. It should be sigterm instead, from what I understand. So I had to downgrade PyTorch to actually get things to work. So I'll really quickly run through what that looked like for me, just in case you run into the same thing. But essentially, if you see a error message talking about there not being a sigkill signal, and it might suggest, oh, is it SIG-IL, which I didn't even know that was a signal. If you see that, you'll know that you're running into this issue where PyTorch, the newer version, doesn't work the way that we want it to. All right, so I'm going to share my VS Code window here for a moment to show what I did to fix the problem to get things working on my system. So I went down here to the requirements linwin collab CUDA file. And so this originally looked like this, so that it took the latest version of PyTorch. I ended up adding a pin to 1.12.1 plus CU116, so that makes sure that it uses this dependency here. So PyTorch 1.12.1 solved the problem for me. I was able to get past the sigkill issue and run the invoke script that it's talking about there. So yeah, once I was able to get past that, I was able to run the Python scripts preload models.py. I had to sign up for Hugging Face, which is a community that has a lot of source code, a lot of shared projects around the AI community, and you have to accept some license agreements first before you can actually download the trained models that we're talking about. But it is using the new Stable Diffusion 1.5 rather than 1.4 that was there a couple of weeks ago. So that's really cool. So then once we get to this point, you actually want to do Python scripts invoke.py -- web to get things started. So to fire things up on my local machine here, I'll show you the steps that I go through. So I have a PowerShell window pulled up here in Windows Terminal. So Windows Terminal allows you to have a variety of different prompts, even with WSL2 different operating systems. So I have my Ubuntu system that I use for day-to-day development. I've got PowerShell 7 added in here. I've got a version of PowerShell that launches as admin, but I don't need that right now. Once I installed Git with Chocolatey and any other dependencies I needed there, then I could close out of the admin shell and go into just the regular user shell, which is a little more safe. So here I am in my regular user shell, and I'm going to go ahead and just use the CLI history so that I don't make typos here. So I'm going to CD to where I put Invoke AI. I stuck it in the pictures folder under Invoke AI. So from here, I want to type work on env and Invoke AI. So you know what? It's not work on env. It is pew work on. PEW. See what I mean about typos? Pew work on Invoke AI. So that sets up my virtual environment. It points all of my Python symlinks and dependencies, all the packages I've downloaded, pins to specific versions that we need. So Python 3.10 is what we're using for Invoke AI here and the Stable Diffusion toolkit. So that's what I'm using in the Pew environment here based on the requirements file and everything. So I've got that activated now. This activates that virtual environment. And so now I can go ahead and just use Python scripts /invoke.py --web. Now, this takes a little bit of time to start up. I have a decently beefy machine, but it's not top of the line. That's okay, though. It does everything that I need it to do. But yeah, it'll take a few moments for it to start up here. So you can see it's reading from the v1.5 pruned file that Runway ML, I think, is the one who puts that out. It's loading all the weights and everything like that and starting the web server. And now, okay, it is ready to run. So I will switch over to my Invoke AI window now. So here is the Invoke AI window. This changed from disconnected to connected once I started running this server behind the scenes. You can see some random images that I've played around with recently. This is me trying to turn Mario into Wario and having a hard time with it, and just some other random stuff that I've put it through right now. It has this main window here. It has a prompt window here. All of this UI has been slightly cleaned up and streamlined since the previous version that I was familiar with, and I like it. It's really nice, and it makes working with all this really smooth. So to introduce you to what all these elements mean, the prompt here is pretty basic, pretty obvious. So let me put in an interesting prompt. I'm going to say the city of Denver covered in snow. Let's throw something quirky in though, with aliens hovering above with psychedelic, wildly colored spaceships. So, all right, this is something totally random. So we have the number of images to generate. So because this uses randomized seeds, which you can turn on and off, you can generate a whole bunch of images in a row so that you can pick which one that you like the best. I'm going to stick with just one at a time for right now. The number of steps is the number of iterations that the AI process runs through to get to the resulting image here. The native resolution is 512 by 512, which is kind of small, but with Invoke AI, you can change that through a pretty wide range here. I'm going to start off with, I'll start off with 1024 by 640. That seems like a pretty decent widescreen format. It'll take it a little bit longer to generate images the larger they are. But then there's also a feature down here called high-res optimization that I'll play with in a moment that can speed things up and give you better results. Let's go ahead and try 25 steps. The different samplers here have pretty varied results. Like they do a lot of different things than each other. You'll see a couple of them seem to be duplicated. This KDPM2 and K Euler A. The A's, from what I understand, are adaptive, and so they come out a little bit different than the standard sampler algorithms here. I'm going to keep it on Euler for right now because I like the results on that one a lot. So let's go ahead and, we've got a randomized seed, and we've got some other settings here. So yeah, let's go ahead and invoke this. So what's happening in the background here, let me present that CLI window again. It is building it right now and running through all of the iterations. So all 25 iterations there. And so it's just about done with that. Oh, it seems to have gotten stuck a little bit. All right, so it took it a few moments. So you can see that's what the output looks like. So let me switch back over to the actual window so that you can see the results, and they are interesting. I don't know if this is quite what I had in mind, but it's pretty cool actually. So I'm going to open this in a new tab so that I can look at it a little bit more closely. But it's not super big yet. You can see the quality degrades as you zoom in quite a bit. But it definitely has a lot of interesting aspects. There's a lot going on in this photo. All right, so let's go back to the main window here. So I'm going to do something that, there we go, zoom back out. I'm going to do something that helps me kind of understand what all the different settings do. So what I like to do is I like to keep the same seed. So I'll click use seed here. And what it does is it uses the same random seed that generated this image instead of randomizing it. So if I hit invoke again, I'll go ahead and do that here. And you can see it kind of running through the progress bar at the top of the screen there. Or maybe you can't see that. Yes, you can. Okay. So anyway, it should come out exactly the same. If I kept my settings the right way, then you'll see it come out exactly the same as it did before. And that's because Stable Diffusion is deterministic. That means that it, based on a certain input, you should always get the same output because the results are entirely derived based on the inputs. So here you can see, yes, the exact same image. I'm going to go ahead and delete this second one here. But it did generate the exact same image. So I know any changes that happen now are a result of the changes in settings that I'm doing here. So the first thing I'll do is I'll lower the number of steps so that you can see what kind of impact that has. So lowering the number of steps will make it run a little bit faster. It generates the image faster, but you'll see the results come out just a little bit different. So here, oh yeah, it's slightly blurrier. It did not affect it very much though. So I've noticed with the non-adaptive samplers, they seem to kind of be stable past 20, 30 steps. Going up to 50 steps or 75 steps or something like that doesn't seem to impact them nearly as much as the adaptive samplers. Let me go down to 10 steps and see what that looks like. You can see that takes less time to generate here. All right, so that comes out even blurrier. So you can see it sharpens it up with each progressive set of steps. So I started out with 25. Let's bump up to 40 to see what that looks like, see how that changes things. It'll take a little bit longer to run. All right, we're almost there. All right, and so there we have the results. So this is 25 steps. This is 40 steps. You can see it pretty much just continues the sharpening trend here, but the difference between 25 and 40 is very slight. There's not much. And so that's something that I've noticed with a lot of the samplers that aren't the -A adaptive ones. I don't know why. Like I said, I'm not much of an expert on this. I've just played around with this in trial and error, but that's an interesting thing that I've come away with. I typically like to keep it on 30 steps. I found that 30 steps seems pretty reasonable in most cases. So let's switch over to KDPM2 and let's see what the results look like there. All right, we're almost done here. Boom. Okay. So it came out and you can see it's a little bit different. It slightly changes some of the shapes that you see. It comes out a little bit more vibrant in terms of colors, in my opinion. I like the results here. This is nice. So let's change to the K-Hune or Huen. All right, so this one came out identical to the KDPM2. That is interesting. I didn't expect that. You don't always see that in this case. So fascinating. Let's go ahead and switch to K Euler A, the adaptive one. And I'll show you here how the difference between 30 and 50 is actually pretty big in this case, or the higher number of steps seem to have more of an impact on the adaptive samplers. All right, so you can see the results of the adaptive are totally different. I'm not sure what's different about it, why it comes out so different. Like I said, I'd like to dig into it more when I have time, but just from coincidental experience here, it definitely brings out completely different results. So let's crank this up to 50 steps and see what that looks like. In past experience, I've seen this be quite different between 30 and 50 steps. All right, so we have interesting, almost like animal shapes in the air now. That's fascinating. And you can see cars on the road down there too. But the buildings have turned into a network of telephone poles, which is fascinating. So you can see how it makes a difference. Let's crank up the CFG scale now from 7.5 to 10, and let's see what kind of a difference that makes. All right, so you can see with the CFG scale increased, you get more vibrancy. The colors came out more intense. There's a little bit more going on with the lighting. It's interesting, the difference it makes. So let me crank it up to 15 now. When you get it higher and higher, it starts to do weirder and weirder things, I've noticed. You can see it churning through the steps in the command line here. But it seems to have frozen. So yeah, like I said, my machine isn't state of the art. So from time to time, it definitely has trouble like this. I assume it's running out of memory or something like that. All right, I'm just going to kill this because it is taking way too long. All right, I'm going to start the web interface back up here. So I canceled out or control C'd out of the Invoke AI process and restarted it. And then it started running smoothly again. So it wasn't the CFG scale of 15 that was causing it. It was something else that was going on. So in the meantime, I looked up what CFG scale actually means, and it refers to classifier-free guidance. So apparently it has to do with how much weight it gives the terms in the prompt, and at higher levels, it tends to distort things more. So this is with the CFG scale up to 15. You can see the lights are getting really bright and intense compared to the last image that we had. And indeed, the further down you go in the CFG scale, the less vibrant it seems to come out. It's definitely interesting. So what I did next, you'll see I have another picture here. I adjusted it back down to 7.5, and I switched to the, which one was it? Which one did I switch to? DDIM. I switched to the DDIM sampler. And so that's what came out with this right here, which is actually nice. I like this result a lot. Let's go ahead and invoke it again here to make sure that I've got the right settings so that it comes out exactly the same way here. But I'd like to play around with this a little bit more because I love the results that came out. So this is, like I said, with the high-res optimization. So you'll notice it did a quick pass at the top, and now it's doing a longer pass. So apparently what it's doing is it's doing a pre-pass and then continuing it, interpolating from a lower resolution to a higher resolution using this DDIM sampler here. So yes, we can see it did indeed come out the same. So I've got the right settings. I'll go ahead and delete that duplicate image. So this DDIM sampler here, what I want to do next is play around with the variations feature. So this is something that I've seen that's interesting. It gives you slight variations depending on the amount that you choose here. From your seed. So if you've got something that you like, but you just want to see subtle differences or minor variations of it to find just the perfect one, you can run it this way a lot. And each time you invoke it, it gives you something slightly different based on the same seed. Oh, wow. That was more than just a little variation. That came out as a total street map thing now. That is fascinating that it gave that much of a variance with that small amount. That's not consistent with some of the results that I've seen before. The other results that I was seeing before were just really little variations. So this is very interesting. All right, I'm going to turn variations off. I'm going to randomize the seed again, and I'm going to try a more basic prompt here. Let me actually find a prompt that I did before. And so I want to demonstrate what this high res optimization does, because it does do something important. I've noticed at higher resolutions, it tends to repeat some of the things in the image over and over again at times. So I'm going to take a moment and find an example from previous on in my exploration that demonstrates this. All right, so I've come down here to earlier on in my history here to find some of the images that I discovered this with. So I've got this image, and you can see it's repeating the trees in all of these images here, repeating the trees a lot. So it looks like a wallpaper pattern. It's not like an actual image. I can use the settings for this. It looks like they changed where that is. There we go. Use all parameters. So I right-clicked here, use all parameters. So this set up the same prompt, the same seed that I was using. It had a variation amount here. I'll turn that off so that we can get predictable results. But I was using the KDPM2 adaptive with 35 steps and a CFG scale of 10. And a pretty large size here. I'm going to keep that large size to demonstrate what I'm talking about. So I will generate this again. I believe this was generated with the 1.4 model. So I'm interested to see what the 1.5 Stable Diffusion model will reveal on this one and how different it'll be from the 1.4 model. All right, so you didn't see it because of the magic of editing, but that took about 5.5, almost 6 minutes to render. So because it's a full, over 1080p image here, it took it quite a while to render, and it comes out a little differently than it did originally, but still with the same kind of repeating trees problem that I was talking about before. So I'm going to take this same exact seed, and I'm going to tick on the high res optimization. And this should actually run a little bit faster. So I'm going to invoke that, and you'll see it do an initial pass that's rather quick, and then it'll follow it up with the full rendering pass. You can see in the PowerShell window here, it starts out with, I said adaptive, but it says ancestral, so I had it wrong. But it starts out with the KDPM2 ancestral starting at step 0 of 35. And then it switches from step 9 to 35 to the DDIM sampler. And it says it's interpolating from 960, 512 to 1920, 1088 using this DDIM sampling. So that's interesting, but that's what the high res optimization does. And as you can see, it comes out totally different this way, but in my opinion, much higher quality. I really like the result here a lot. And yes, it still has heavy trees in the background, but it's a little better. It definitely looks greater, and it's a full 1080p image. So if I open it up in a new tab here, you can see you zoom it in and it does well. You can get in really close and it still looks quite good here in the rendered results. The deer look a little bit funky. That one has a quite interesting face. But yeah, generally, it's much better results in these higher resolution images when you use that optimization setting. All right, so another feature that Invoke AI provides is this image to image. And so that's where you can take an image and tell AI to turn it into something else. So let's take this raven picture from before and let's send it to image. So you can see on the left side here, I've got the image, but let's tell it to create a vintage old Western photograph out of it. So the left side should be the original image and the right side should be the resulting image. I'm going to turn the CFG scale back down to 7.5, and I'm going to give it the K Euler A sampler here. Going to drop that resolution way down here to speed things up quite a bit. Well, no, I'll give it the classic 1024 by 768 height. So let's tell it. Now, this is important. This image to image strength. This controls how much the resulting image resembles the original image. So I'm going to start it off at 0.5 here. I'm going to go ahead and randomize the seed and turn off the high res optimization because we don't need it so much here. So let's go ahead and invoke this and see what it looks like. So moving over to the PowerShell window, you can see it's doing things a little bit different here, and it is taking its sweet time. I will say it doesn't consume so many resources when I'm not recording a video, so I'm sure that has something to do with it. There's some kind of hardware video encoding going on that's interfering with the AI image generation. It definitely seems to be a little faster when I'm not recording a video. All right, so the results come out kind of strange. This is not what I was expecting. It turned it into a horse a little bit, and maybe, yeah, because I said vintage Western photograph, so okay. If I drop this image to image strength down a little bit, I mean, it does illustrate my point. You can see it changed the original a little bit, but it definitely is still very close to the original image. So let's crank that image to image strength up quite a bit. Let's bring it up to 75. And this will play a role in the inpainting also. And yeah, let's keep the seed randomized. So let's see what that does for it. Oh, okay. That gives us some interesting results. It turns it into a vintage old Western photograph in the shape of the original Raven. That's fascinating. All right. So let's play around just a little bit more, and then I'll switch over to the inpainting. Let's give it fewer steps and see what that looks like, and more of a classifier free guidance scale. Yep, we're still getting variations on the same thing here. So I'll drop it back down to 5, and then let's drop the CFG scale down to 5 and see what that does. Now, it's still randomized. There's still a randomized seed here, so the results won't be quite as stable as when I had pinned to a specific seed and it was just playing around with variations, but it'll still be interesting to see what it comes up with. Okay, so yes, I dropped that image to image strength down quite a bit, so it still came out very close to the original image. You can see it kind of turned it more into a painting, but yeah, not quite the dramatic difference that I was expecting there. All right, so let's switch over to the main flagship feature of the 2.1 release. This is Inpainting. So you can see I already have a Mario image queued up here. This is something that I was playing around with earlier. I wanted to turn Mario into Wario. So you saw some of my images down here of there's Mario as a baby. There's an interesting Wario. I think this one's my favorite that came out. That mischievous grin is pretty great. You can see some weird results like totally blurry Mario. We got more cartoony, more blobular results. That one's really fun, I think. So Inpainting, how it works is it uses a mask. So I don't have the mask set up here. I had it painted before. You paint the mask with a brush. So I'm going to paint Mario with a mask here so that we can inpaint with the AI and change this up without changing the rest of the image around Mario. So that's what inpainting does. It creates this transparency region that you originally had to create yourself with a graphics program. And so that's one of the really big things that Invoke AI does for you, is that it helps you create this transparency region easily like this. So I'm just going to replace Mario's face here. And so let's change Mario into cow. Let's give it a try. So I'm going to keep the K Euler sampler. I'm going to keep 25 steps here. I'm going to crank the CFG scale back up to 7.5. And yep, got my randomized seed. So let's see how this comes out. That does not look like a cow at all. It kind of looks like a Wii kind of painting version of Mario. The eyes are interesting, but okay, let's pin to this seed here. Let's use the same random seed, and then let me increase the image to image strength. So I'm going to bump that up to 0.6. And the results come out more looking like a pig than a cow. That's interesting. Okay. So now let's give it 0.75. So basically, the more you give it, the more strength you give this image to image, the more effect it will have on it. And this is just a weird result. I'm going to go ahead and bring the random seed back because I think we're getting worse on this. Whoa, what even is that? I don't understand. Let's look a little closer at that. Oh, there's some eyes, and oh wow, it's like a Play-Doh mess. That's interesting. All right, so let's drop that image to image strength back down a little bit, and let's make it a smiling cow wearing a Mario hat. Let's see how that changes things up a little. So you can see, since Inpainting is acting on a much smaller region, it takes a lot less time to work. And that is strange. It just kind of made a variation on Mario's face. So let's bump that image to image strength up a little bit. I'll pin to that seed again and try again and see what we get. Okay, so even by bumping the image to image strength up quite a bit from where it was before, it still didn't change things that much. It gives Mario this kind of crazy, wow, he does not look okay. He looks like he might be having a side effect of some kind of medication or something. Yeah. So that didn't change things as much as I really thought it would. So I'm going to bring the randomized seed back again and see if we get a different result by triggering it again. It really is not giving him much of a cow-like look. So I'm gonna crank it up even more. I'm going to pin that seed again so that I can see what the actual effects are, but I'm giving it a 0.9 image to image strength. It might just completely come out garbled. We'll see. Whoa, what is this? All right, so yeah, but that's interesting. I don't even know how to describe that one. All right, so one thing that's interesting is this in-paint replace. If I turn that off, I get less smooth results, I've noticed. I'm not sure totally what that does yet. I'll have to look it up, but the results that come out are a little bit, yeah, in this case, it's repeating things a little bit. It's fascinating how different things come out. I'm going to go ahead and crank this up to 50 steps. Now, I've noticed in the in-painting, more steps does actually change things, even when you're not using one of the ancestral or adaptive scales or anything like that. So it's interesting to see. Let's see what 50 steps do here. You can tell it's taking a little bit longer, but not long. The in-painting really is faster. Oh, and it cleans things up a little bit. Not enough, but a little bit. So let's bring that randomized seed back and see what else we get here. All right. So in this case, though, I can really say it does not look like a cow at all. Other results that I was getting did seem to be a little bit more on target to what I was asking for in the prompt, but this has been kind of a totally weird random set of Mario expressions instead of anything else. So the in-painting is definitely interesting and not quite as predictable as I was thinking that it would be. Oh, okay. So by taking the wearing a Mario hat out of the prompt, I do get a cow. This now does look like Mario with a cow. So that is interesting. That's fascinating. It doesn't quite look natural in any way, but so let's take this and then crank that image to image strength back down a little bit. So something that you're not seeing because of the editing, it is getting stuck a lot. I think it's because I'm recording videos, like I was saying. It is freezing up a lot and seeming to run out of memory. Oh, bringing that image to image strength down to 7 did give it something much more resembling Mario as a cow. That is actually a lot better. So this is the kind of situation where I would pin that seed and then I would play around with variations. So I wouldn't change anything else. I would just change the variations a little bit and see, okay, let's try it out here and see, does it give us something slightly similar to this, maybe more of a cow face or something like that. Wow, yeah, it was really struggling there for a second. Oh, okay, so yeah, you can see that slight variation did change things a little. Whoa, the expression on that face, that is interesting. All right, so yeah, you can see, oh yeah, I was going to share it blown up a little bit. There it is. Wow, that's, all right. So let me turn the Inpaint replace back on and just see with these same settings. Oh, it's going to give me a variation. I forgot to turn the variation off. That's okay. I do want to see what the Inpaint replace does differently here. Okay, so it didn't really improve things per se, but it did come out a little smoother, a little more higher resolution. I feel like a little more crisp, but I don't know what this lumpy thing here in that ear. Wow, that ear coming out of the jaw. That's interesting. All right, so yeah, you can see it takes a lot of fiddling around, but you can get some astonishing results with it. I will pull up one of the earlier ones I did here. Oh yeah, with Iron Man. So I created that was the first attempt. Iron Man Keanu Reeves. So this is a case where I used, I told it Keanu Reeves. I used the K Euler sampler. I did do the Inpaint replace here, I think. I can't remember if I had activated that at the time or if that's just carried over from what I did from a moment ago. But the source image, I'll pull up here. So there's what it originally looked like with Keanu or with Robert Downey Jr. And then there's the Keanu version. I don't know. I think it could work. Keanu could be Iron Man. All right. So that's all I'll show off for today. Like I said, I didn't actually work on any of these things. This is just me appreciating the work that I'm really glad that the Invoke AI team shared. And so thank you for sharing this work open source. Thank you for allowing the community to work with you on making this better. This is really a fantastic, fun tool to play around with. I've loved the results that I've gotten with a lot of different things here. Some of those images that you see, like the background image on my feed right now, really excited about the future of the technology as it grows. It's already moving into video, both at Facebook and Google. It's really, I think, going to change the way that art is generated, and it introduces a lot of really thorny questions around attribution, around rights, around copyright, around compensation for people whose styles may have been borrowed. Like looking at this image of Keanu here, this obviously is entirely the work of somebody else. This is not my art here. The generated Keanu face there may have been taken from a bunch of different images, or perhaps thousands of different images, and kind of pieced together. But those images definitely had an influence on how it came out. And so there's an open question around how much attribution, how much compensation that those influences deserve in these cases. And how do you even keep track of that? If you've got AI dreamers pulling from hundreds of thousands of different sources to create one image, how do you calculate some kind of compensation for the origin of those images? I know there are startups out there that are trying to tackle this question and trying to navigate these thorny issues legally, as well as trying to work out different ways of approaching this with trained models using content that is licensed or things like that. I know the first big AI court case is on its way right now, dealing with GitHub's Copilot feature, where it takes a massive database of open source code stored on GitHub, and then combines it together to automatically program for you. So who is responsible for the works derived from these things is definitely an open question, and it's interesting to see how this will all play out. In the meantime, though, it's a really fun Wild West to play around in. It's got a lot of quirky, radical things that you never would have imagined that you could generate just by typing prompts and playing around with a bunch of different settings. So definitely, if you have a computer with a video card that has enough VRAM, enough onboard video RAM, that it can do things like this. Like I said, my RTX 3070, it's a relatively new card, but it's not the top of the line, and it's not the latest generation. There's a 4000 series that NVIDIA has put out just recently, like the 4090, which is just a massive behemoth of a video card with quite a price tag associated with it as well. But really, the 3070 has been fine for not only 1080p gaming, which I love, but also this taking advantage of these generated models with things like Stable Diffusion. But if you want to train your own models, if you want to add your own face or the faces of your friends or family into things, you're going to need to get a 3090 or above currently. I imagine that will change over time as more optimization is discovered, but I definitely would recommend you giving Invoke AI a shot. It is not too hard to set up, except for little things like the PyTorch issue that I pointed out at the beginning of the video. And I would love to see the creations that you've come up with. So share a link to your creations in comments, or let me know on Mastodon. I'm on the fostodon.org instance, and you can find the link in the show notes here. I'd love to hear from you. Thanks for watching.